Welcome to this session on MongoDB. At the outset, what I want to say is this video is basically a very basic introduction of MongoDB and primarily intended for people who are yet to actually delve into MongoDB. So basically for junior programmers or college or university students. But also this video has some of my key learnings about MongoDB, which a little bit moderate user can also find interesting or useful. So with that said, let's get started. I'm Shomik, who is a software developer cum consultant who would be presenting this session. Welcome once again to MongoDB. And first we are going to see what is MongoDB and why do we really care about that. So MongoDB is basically a distributed and document-oriented database. By distributed, what we mean is the database actually is set up in multiple machines, which means the database itself consists of multiple nodes for better availability, for better scalability. And later on, we will see exactly how that is set up in production. And document-oriented database is one of the closest NoSQL database types, which is closest to a relational database, with definitely some differences. Like we call the tables, we typically refer the tables as collections and the rows as the documents. It is very similar to RDBMS with some major differences, like there is no fixed schema. So we can actually start inserting records or start inserting documents without even creating the table, without even creating the collection. And it is distributed by design, as I mentioned, which means it is very easy to scale it. Now, the next important question is, why should we care about MongoDB when there are already very good RDBMSs out there? Now, what I've realized and what I've understood over time using MongoDB is it is ideally suited if all of the following conditions are met. Like the data volume grows at a very fast pace, and the schema can also evolve in future. And also we require very fast insert speed and also reasonably decent read latency. So now we will see how we can actually do a quick small dev setup of MongoDB and see how we can actually insert some documents, insert some rows in a collection of MongoDB, and how we can query for it or how we can update or delete that. In order to do that, we'll have to first download the community edition of the server from the link given here, and then we can download the either the GUI based client or a CUI based client. Now we will see typical examples of some queries of MongoDB. Here is an example of an RDBMS query versus a MongoDB query. As you can see, the typical RDBMS query you probably can relate to, insert into the table with the values. On the MongoDB world, the query you translate to db.employees.insert1, and then the actual data is always given in JSON in MongoDB. You will see the same thing in the select query. So in the select query, as you can see, it selects star from employees when name equal to Shomik. The MongoDB equivalent is db.employees.find, and then the criteria. The criteria is always given in a JSON format. And then the update syntax, db.employees.update1, and then on the left hand side, the criteria for update, and then on the right hand side, after a comma, $set, like what we want to update to, and finally the delete syntax. So this is in a nutshell how the CRUD query of RDBMS translates to the MongoDB equivalent. Now we will see exactly in a very small dev demo how the MongoDB server can be actually started in a dev laptop, and how a MongoDB client can be used to connect to that MongoDB server and execute some queries. Okay, so let's see a quick demo of a dev setup of MongoDB server and the client. First, let us download the MongoDB server from this URL. Please click on MongoDB community server on the left. and from here you can download the MongoDB community server corresponding to your operating system. So if you are on Windows, I would recommend you to download the zip package, and once you have downloaded the community server, then please go to this URL to download the tool, which is the MongoDB shell, which is the client part of the setup via which you can query the server. So there also you can download the corresponding version for your operating system, and I would recommend you to download the zip package if you are on Windows. With that said, once you have downloaded, then let us see how we can start the MongoDB server. So I'm on a Unix environment, which is Ubuntu, but conceptually it would be similar if you are either on Windows or on Mac. So essentially the MongoDB server executable is this program, which is MongoD. So what we have to do is we have to run MongoD in order to start the MongoDB server. So let's see how we can do that. So the command would be so the command, as you can see, MongoD and then --db path, and then basically I had created an empty folder, an empty directory where the MongoDB will store the created data files. So this is the entire command to actually run MongoDB, regardless of whether you are on Windows or on Unix or on Mac. So MongoDB has started, and MongoDB starts by default on port 27017. And now we will start the Mongo shell, which we have also downloaded and installed. And if I click here, so then the Mongo shell starts. And if I do a show DBs, it shows all the DBs. We can use the local DB. And then maybe we can just execute the command. So we are trying to insert one document or one row, and MongoDB has acknowledged the insertion. And if we try to now find out what we have inserted, let's see. So it has returned the document, and what you can see here is there is an additional field or column which has been returned, which is this object ID, which is an unique number. And this is something which MongoDB adds to any row or any document which you create. It's basically a primary key which it uses internally to track every single document. We can then update the document, or we can also delete that document. So this is how from this shell you can actually interact with the MongoDB server locally, and then you can also exit from this shell. That's it. Now I'm going to share some of my key learnings of MongoDB, which can also be your key takeaways from this session. Number one, the insert speed of MongoDB is normally much higher than any RDBMS, and the reason behind that is for MongoDB insertion, we do not need to do any, or rather MongoDB does not need to do schema validation, which any RDBMS needs to do. Since the insert speed of MongoDB is very high, people who want to experiment with MongoDB sometimes start storing their application logs in MongoDB. The advantage of that is since the insert speed is high, so it does not affect the application performance. And second is, since MongoDB has very rich query ability, you can actually query the log much easily. So storing your application logs in MongoDB is one of the very basic use cases which I've seen being used at many places. Key takeaway 2. The second learning with regards to MongoDB is the typical distributed architecture of MongoDB. And I would like to spend some time on this particular slide because it is really very important for us to understand this distributed architecture. Now, if you look at this Mongo cluster here, which we are primarily going to focus, there are total, say for example, there are total 9 machines or 9 systems or 9 nodes uh, which comprises the Mongo cluster. Out of that, you see I have denoted 3 as P, which means primary. So P1, P2 and P3 are the primary nodes which accept the write load. But they share the data, which means, say for example, we have 300 gigs of data, then we can think of this like the first 100 gig is stored in P1 and the second 100 gig is stored in P2 and the third or the last 100 gig is stored in P3. And S1, S2, S3, S4, S5, S6 are the secondaries, which means this P1's 100 gig is replicated into S1 and S4, which means if P1 fails, then any one of the S1 or S4 can become primary and the other will remain as secondary. Similarly, for P2, S2 and S5 are the secondary, and for P3, S3 and S6 are the secondary. So this is a typical distributed cluster setup of MongoDB. It is important to understand that the data is split across into different systems. So that is why if the data volume increases, we can increase the number of nodes easily, and thereby we can actually scale easily. So that is why MongoDB is horizontally scalable. And also it is available because for every primary we have multiple secondaries, so that if the primary fails, then any one of the secondaries can become primary. Now what is another good thing is it is really easy to set up such a distributed cluster of MongoDB. It really does not require any advanced database or system administration skills. It is rather easy for you and I to actually easily set up a MongoDB cluster. I'm not going to do that in this video. Maybe I will create one video to illustrate that. Next learning. The schemaless feature of the MongoDB, which means that we do not need to pre-create tables. We can create rows with different types of columns or column names, is a feature which can be very useful if you do not know your future schema or your schema actually evolves with time. Now you might think that RDBMS also has the ability, also gives you the ability to alter the table and add column in future. But the primary difference with MongoDB is, or with a document-oriented database is, a document-oriented database is a schema-less ground up, which means unlike RDBMS, the columns which do not contain data for specific rows, they do not exist at all. So they do not occupy any space. So that is the schemaless feature. And the fourth takeaway is there is a nesting capability of MongoDB, which means you can nest one document within another document. And this can actually yield better performance even for read workloads than complex joins, which we normally do in a traditional RDBMS. Now, this is also a topic which requires detailed discussion, so I'm not going to go into much detail on this topic at this moment. And finally, I would like to share the PAC ELC rating of MongoDB. So MongoDB is basically a very strongly consistent system, which means MongoDB always tries to lean towards consistency. But normally during a normal setup, MongoDB definitely leans towards consistency. So that is why it's an easy system. But during a network failure, it tends to give more weightage to availability, and hence it is known as a PA system. If you want to know more about back ELC theorem, you can refer to my other video about the NoSQL databases in general, where I have also discussed about back ELC theorem. Come towards the end of this session, and I would like to appeal to you that if you have found this session to be useful, and if you have liked this session, then please subscribe to my channel and like this video and share this video with your friends or whoever you think wants to learn MongoDB and would benefit from this video, because that would really motivate me to produce more useful contents in future. Thank you very much.